All right. L'Hopital's rule. Now, yeah, it's not La Hospital, it's L'Hopital. Yeah. So, if you remember way back when we did limits, okay, and let's say we had the limit as x approaches 3 of this function. Nice thing is we can just plug it in and get 2 times 3 minus 5 over 3, which gives you 6 minus 5 over 3, or 1/3. That's fine. We're done. That's the limit. Everybody's happy. All right. But what happens when I put the limit as x goes to 2 into the next function? Well, that is going to give me 2 squared minus 7 times 2 plus 10 over 2 minus 2, which is 4 minus 14 plus 10 over 0, or 0 over 0. Now, anytime we get 0 over 0, that usually means we can simplify by either factoring and canceling out the value. So, for example, we could factor this to be x minus 2 and x minus 5, and then cancel out the x minus 2. We take the limit as x approaches 2 of x minus 5, which gives you 2 minus 5, or negative 3. Now, anytime we get 0 over 0, that's what we can do. We would have to simplify. Now, sometimes it's that easy. Okay? Other times we had to rationalize, okay, the numerator or denominator, or we had to get rid of the complex fractions. Okay? So L'Hopital has found a much easier way to do this. Okay? Anytime that we get 0 over 0, okay, or infinity over infinity, L'Hopital's rule allows us to do this. We take given that this is the limit, we take the limit as x approaches a of f prime of x over g prime of x. Now, this is not quotient rule. We take the derivative of the numerator and denominator separately. Okay? So we take the derivative of the numerator, then we take the derivative of the denominator, and then we take the limit of the result. So for example, all right, as limit as x approaches 2, what's the derivative of my numerator for my first question? Well, that is 2x minus 7. What's the derivative of my denominator? 1. If I plug in 2 now, I get 2 times 2 minus 7, which is 4 minus 7, which is negative 3. That is L'Hopital's rule. Now,
hospital coming in correct, bro.
Yeah.
Where was El Hospital?
Wait.
So, what happens though if you still get 0 over 0? You take the derivative again. And if you still get 0 over 0, you take the derivative. You just keep going until you don't get 0 over 0 anymore. Now, is it still possible that the answer does not exist? Yes, it's still possible. But as long as you get 0 over 0 or infinity over infinity, okay, you keep doing the derivative until you no longer get that. L'Hopital's rule only works if you get 0 over 0 or infinity over infinity. Okay? So, what we're going to do is show that we have L'Hopital's, that we meet the condition for L'Hopital's rule. If I plug in 2, I'm going to get 0 on the numerator. I plug in 2, you are going to get 0 on the denominator. Okay? So, we are now going to take the limit as x approaches 2 of my derivative, which is 1, over 9x squared minus 12x plus 1. That gives me 1 over 9 times 4 minus 12 times 2. That's not a 12. Minus 12 times 2 plus 1, which is 1 over 36 minus 24 plus 1, which is 1 over 13. Do you remember number 3 here? It's been a while. So I'd be a little surprised if you did. It's 6, yeah. So the answer is 6. Because if you remember, we could show you that if we had 6x in the denominator, this just becomes 1, and we'd have 6 outside to balance that denominator out. So we had 6 times 1 gives you 6. That's from that rule from a long time ago. So instead of knowing that rule, though, you could just do L'Hopital's rule. Because if you plug in 0, sine of 0 is 0 over 0. So it does work. Now we take the limit as x approaches 0. Back out. And we take the derivative. Derivative of sine 6x is going to be 6 times cosine of 6x. Derivative of x is 1. So now when we plug in 0, we get 6 times cosine of 6 times 0, which is 0, which is 6 times 1, or just 6. We doing okay? Most people generally tend to like L'Hopital's rule. And I get a big thing. L'Hopital's not quotient rule. All right, number 4. Zoom in here a little bit. Is that better? So here we, again, if we plug in 0, we get 1 minus 1 over 0 squared, which is just 0, so 0 over 0. So we take the limit as x goes to 0, take the derivative, gives us derivative of cosine is negative sine, but because we have a negative already, we get sine x over sine x over 2x, right? All right, so I plug in 0 here, I get sine of 0 over 2 times 0, which is 0 over 0. So we do L'Hopital's rule again. Limit as x goes to 0. Derivative of sine is cosine. Derivative of 2x is just 2. So it gives me cosine of 0 over 2, which is 1/2.
What is the data? Is it going to be into yeah. What is it called?
All right. Number 5. If we plug in infinity, we will get infinity over infinity. Okay. So we take the limit as x goes to infinity. Derivative of 2x squared is 4x. Derivative of e to the 2x is 2 e to the 2x. And if I plug infinity, I get infinity over infinity. All right, so we take the derivative again. Limit as x goes to infinity of 4 over 4 e to the 2x, which again, you can reduce that if you want, but it makes no difference because when you plug in infinity, you get 4 over infinity, which is 0.
Only under the derivative again because this just equals
It's okay to equal 0. It's not okay to have infinity over infinity or 0 over 0. Now, this last part, again, is like what I said before. This is not the same thing as quotient rule. If notice that this doesn't say limit. Okay, it doesn't have limit. It just says take the derivative of this. Well, that's just quotient rule. So that's going to give me the derivative of sine 6x, which is 6 cosine of 6x times x minus derivative of x is 1 times sine 6x over x squared. And the only thing left to do is maybe simplify this as 6x cosine of 6x minus sine of 6x over x squared. That's just your general quotient rule. Okay, so that's it, nothing else. Basically, I'm just trying to make sure you remember the difference between when can you use L'Hopital's rule and when you have to use quotient rule. Do not mix the two up. And that is it for Unit 4. So tomorrow we will have a review. And then